everyone. Today we're going to be talking more in depth about vectors and vector operators. So in the last video we learned about scalars and vectors, more specifically about the displacement vector, shown here as a vector running from A to B. We know that vectors aren't anchored, so that they're the same anywhere throughout, so all these lines here represent the same vector. We can represent a multiple displacement with a single overall displacement vector, the net displacement, where, say, AC is the vector sum or resultant of two vectors AB and BC. Let's say we have two vectors AB and BC, which are part of two separate motions. The vector AC here is the resultant of these two, a single displacement vector that represents the net displacement. We use the head-to-tail technique here, where we place the head of one vector at the tail of another vector to add them together, and this can be represented in a vector equation like this. Now, a couple of properties of addition that we should be familiar with are the commutative and associative properties, which say that first, the order of addition does not matter, so AB plus BC is the same as vector BC plus vector AB. And also, when doing vector addition, we can group them in any way we like and get the same resultant vector. The last one here isn't really a property, but it's important that we know that subtraction of a vector is really just adding the negative vector. If we look at these two vectors and want to subtract the blue vector, then we'd simply just flip the vector around by 180 degrees and add them together to get our new resultant. This works because we know that a negative vector is just the same vector magnitude, but in the opposite direction. Okay, now moving on to multiplication of vectors. More specifically, multiplication of vectors by scalars. So recall that scalars have a magnitude but no direction, which means that if we multiply a vector by a scalar, then it kind of changes the length of the vector if we think about it visually. Imagine it as kind of shrinking or elongating the vector arrow. Here we have a random vector, let's call it A, and if we multiply it by 2, so 2A, it doubles the length in the same direction as the original vector A. And multiplying it by 1/2 would just cut the length in half. Now multiplying by negative 1/2 would cut the length in half while also flipping the vector A around in the opposite direction. Okay, that's it for this video. Thank you for listening and hope you've learned something new.